In this tutorial, we're going to talk about solving logarithmic equations. The first step to solve a logarithmic equation is to isolate the logarithmic term on one side. So you can see in our examples here, our logarithmic term in this case would be the log of the quantity 2x, and here the natural log of the quantity 2 plus x. So over here, it's isolated already, but on the first equation, it is not isolated. So the first thing we need to do to both sides here is subtract 4. So we could say 3 times the log of the quantity 2x equals 12 if we subtracted 4 from both sides. And then that logarithm is still being multiplied by 3. So then we'd want to divide both sides by 3. So we could say that the log of 2x equals 4. And again, over here, this is already set up for step 1. Step 2 is to write the equation in exponential form. So that means that if I'm going to rewrite this side, well, a log, if the base isn't written, we know that it's a base of 10. So if we rewrite this, this says 10 to the 4th power equals 2x. Versus over here, the natural log, we know this is a base of e. So this would be saying e to the 1st power is 2 plus x. After it's written in exponential form, we want to solve for the variable. So over here, we would know, well, first of all, 10 to the 4th means a 1 followed by 4 zeros. So 10 to the 4th is 10,000 equals 2x. So to solve for x, we need to divide both sides by 2. So that would mean that x equals 5,000 in this case. Over here, to solve for x, we would have to subtract 2 from both sides. So this would be e to the 1st power, or just e, minus 2. In this case, we would want to type this in our calculator. So you would be able to say e, or e to the 1st power, minus 2. And that would give us 0.7183. So this is about 0.7183. But we wouldn't be able to do this without a calculator anytime that it's involving an e term. So the only other one that I want to show you is an example if you have multiple logarithms, like this example here. So we have 2 log of x equals log of 2 plus log of the quantity 3x minus 4. So the first thing I want to do is combine my logarithms on the right side. So since they both have a base of 10, that means that we can rewrite this as the log of when we multiply these together. So the log of 2 times the quantity 3x minus 4, right? Because when you're adding logs with the same base, that's the same thing as the logarithm of the product. So if I were to distribute the 2, we could say that this is the log of 6x minus 8. And over here, 2 times the log of x, I would be able to rewrite that as the log of x squared. Now, hopefully you can see the reason that this is helpful to us. If we have the log of x squared equals the log of the quantity 6x minus 8, since these are equal to each other and we have a logarithm on each side that's a base 10, that means that this quantity, the x squared, what we were taking the logarithm of, should equal this quantity. So really what we're saying here is x squared equals 6x minus 8. So this is a quadratic that we would need to solve. So we would say x squared minus 6x plus 8 equals 0. And I know that this can be factored to x minus 2 times x minus 4, which means x equals 2 and 4. It's always a good idea to plug your answers back in to check. So you could do that using your calculator, or you could, just go through it and make sure that it would actually work by plugging each in individually, but you would want to always check your answers to make sure that they make sense back in the original problem.